Hi, I'm going to explain what is so-called an isoprofit line solution method for a linear programming problem. Let's say we have this linear programming problem and we're going to solve for it. How can we start? Well, we can graphically solve it by first graphing the so-called feasible region. And here it is. So feasible region is the region in which all of the points satisfy all of the constraints. With that, our goal is basically to find within this feasible region which point or which points will maximize this objective function. Isoprofit line method involves 3 steps. I'm going to explain those 3 steps one by one in the following slide. To start off, I'm going to assign an arbitrary value to the objective function. Let's say I choose 2100. So that means the objective function looks like this. So it's a line. I can draw this line on the graph. So let's do it. There are many ways to draw a line on the graph. One of the ways, the way I choose, is to find the intercept to the axis. First, I set t equal to 0, which means that c will be 42 from solving this equation, which means that, well, 0, 42 is a point on this line. Similarly, I can set c to 0. Solving this equation, I get t being 30, which means that 30, 0 is another point on this line. Here are these 2 points. I can connect them, and that is this function. We call this line an isoprofit line because every point on this line will give you the same objective value, 2100 in this case. Okay, well, is 2100 the best we can get? Apparently not. Let's try another number. Let's increase this number a little bit. Let's say 2800. And I graph this line here. Apparently 2800 is a better solution, better objective than 2100, and we still have, and it still intersect with the feasible region. So we can improve our objective from 2100 to 2800. And can we do any way better? Let's try another larger number, 3500. Well, it looks like this. So yes, we can keep increasing this number, and we observe that as we increase this number, this isoprofit line moves up. So we can keep doing that all the way until like this, until the line intersects exactly at one point with the feasible region. At this point, we cannot further improve or increase the value. Okay, so what is this point? This is our optimal solution then. So it's the intersection of these 2 blue lines. So we simply can find this point by solving these 2 equations with 2 unknowns. Turns out to be this point, 30, 40. So this is our optimal solution. So let me recap what is essentially the isoprofit line method. It has a very simple concept. So we started off by drawing an isoprofit line and then move it toward the direction that improves the objective value. By the geometry, we know that the optimal solution will occur at the situation where the isoprofit line intersects with at least one of the corner points of the feasible region. So what is the purpose of drawing the isoprofit line? Essentially, the purpose is to find the slope, how steep this line is, so that we can move around it and find out where does it intersect with the corner points of the feasible region, because that corner point will be our optimal solution. Furthermore, the geometry I just showed you also reveals a very important characteristics of this optimal solution. The optimal solution of an LP problem definitely contains at least one of the corner points of the feasible region.